Hello everyone. So let us continue our session on the peak. We discussed about the introduction to peak, what is peak and what is the architecture. Now we are going to discuss about the commands. There are various kinds of commands available in the current shell. Okay. In that fs is a command that can be used to execute any file system commands. Okay, so if you want to, once if you enter into the grunt shell, if you want to execute the file system commands, then you can give the fs and space, you can give the command. And then exec, if you want to execute any pig script, it's Latin, pig Latin, then you can use this command exec. And run is also for execution of the pig Latin. Okay, so exec, there is a small difference between these two. Exec, it will take that entire code, whatever you have given the script, that will be loaded into the current environment, and it will execute, and it reminds the variables which are used in the script. That is the exec. Run, what it will do is it will just take the code and execute it and leave whatever the variables or relations available, they will be clear once the execution is over. So these are the two differences. Of course, we are not using much about these commands. Now we are going with the grunt shell directly. So for the grunt shell, if you want to go with the grunt shell, you should go with some components. Like, what you have to understand is the data types. Data types are available. Like MapReduce and the HDFS, we have different data types because they are the streaming. Actually, the Hadoop concept is the streaming environment. So the pig Latin, it is having its own data types to handle various kinds of data. So scalar types are there: int, long, float, double, character array, byte array. Please remember that character array is for the string, byte array, and complex types are also there: map, tuple, and bag. I think map, you can understand that it is like the dictionary kind of environment in Python. Tuple is also tuple, like same as the tuple. Okay, the collection of number of elements. Okay, and bag means it is the, we can say that it is the list of tuples. We can say that it is the list of tuples. Okay, so like that, there are several types available. Okay, and null, schemas, cats, all these are the various other components of meaning that the other big data types. Okay, now we have to discuss about the schemas. What is the schema actually? Schema means data about data. What is the data about data? Let us say, for example, if we have the data set like 1 comma Rama comma 5,000. What is that one? What is Rama? What is 5,000? Who will specify that? That is called, one is the employee ID. Two, Rama is the name of the employee. 5,000 is the salary. If we mention clearly that what is what, which data, which column is representing what, if you are giving some description, that is called the data about data, that is called the metadata, that is called the schema, meaning that it will describe what is the data available clearly, that is called the schema. Now pig, if you load some data, the pig, it will follow some schema. What is that schema? That is, if you provide the schema, if you provide the schema, it will use that schema. Otherwise, it will guess the schema. What is the schema? It will guess automatically. Meaning that if you load some data, for that data, according to that, what are the data types for each column, that will be decided by the pig, and it will guess what is the data type, and then it will automatically assign that. Okay, that is the guessing of the schema. And it includes the field names and the data types. All these are included automatically. And field names, if you want to give the field names, you can provide the field names like ENO name, M1, M2, M3, like that, you can give. Otherwise, you can, it will give the field names. If you don't provide the field names internally, it will give some field names, that is dollar zero, it will starting from dollar zero, dollar zero, dollar one, dollar two, dollar three, and so on. All the fields they will have some numbering. Yeah. So, and these are the schema, these are the data types which are useful for the schema: int, long, float, double, character, byte, array, map, tuple, and that. Okay. Now, what is this pig Latin having? That is, the as I mentioned you, we have the data set, some data set, and we will apply some process, and then it will change the state of that data. The data set in one state, it is in the data set one, that is in one state of data. If you apply the process, it will give you another state of data. So that is the data flow language. Okay. And now, what is this data set 1, data set 2? This is represented as the relation. The data set can be represented as the relation here. This is one relation, this is one relation. A relation will be given as the input to the process. That process will processes and creates another relation. Okay, the relation, it may have several fields again. Okay, that what are those fields that we will discuss. Okay, now pig in the pig Latin, we have several kinds of commands available. That is input output commands, relational operations, UDFs, streaming, map reduce, and setting the environment. All these are the various kinds of relation, various kinds of statements. In this session, we are going to discuss about the input output statements and relational operations. Now let us go with that. Input output. Load is the input operation. If you have the data in the HDFS, you can load that data into pig program, and then you can work with that. And again, if you want, you can write it back. Okay, that is the input output statement. So for loading the data, for taking the data as the input, that is the load operation. Okay, it may include the schema or it can guess the schema. Okay. Now the syntax is load file name. You can give the file name in the quotations using loader function. Using some loader function you should provide, and then you should provide the parameter. What is that? As you have to provide the field name one data colon data type, comma, field name two colon data type, and so on. How many fields are there? You can mention those many number of fields. You can see that here, this is a small example for that. In the Grunt shell, we are providing that A equal to load empj1.csv. This is the file available in the HDFS, right? So you have to provide the complete path also. That is another process. And using pig storage, using the loader function is pig storage, and which is separated by the comma. If it is the comma separated, you have to provide that as comma. If it is the tab separated, you have to provide backslash t like that. And as envo int name character array, salary int, did int, because the data in the empj1.csv is in that structure. Because of that reason, how the structure is available in the data set, the same structure you have to provide that here. So before creation of this, before writing this load function, first of all, you should know what is the data given. You should be aware of that. Then you can create, you can load the data set. Once if you load the data set, you can give that, you can give the describe command, describe A, so that it will give you what is the description of the schema. The schema is having A is the relation name, and uh, ENO is int, ename is character array, salary is int, DID is the department number, department ID, it is integer. So like this, it will provide the schema, right? And then yes, this is the default. By default, it is that backslash t pick storage, and default uh, the name will be the by default it is the dollar zero, the field name, and by default the data type is the byte array. Okay. Now let us go with the other thing. If you want to store it back, this is the loading. Load function is for input. For output, if you want to store the data onto HDFS, we can give the same function, same syntax. We can use the same syntax. Store C into join result using pig storage of comma. So that now while storing the data set, you need not give the schema because already we have the schema. We are writing the data onto secondary storage. So that it will be written back to the HDFS in the given file name. The given file name that will be written, and it will give you total records written is 9, total bytes written, and some statistics will be given. This is the loading and storing. Load, store. This is for input, output. Okay. And now relational operators are available. What are the relational operators? For each, filter, group by, order by, distinct, join. If anyway you are familiar with SQL, so you can easily understand this. Now let us go with that. For each. For each means it is a command to apply a given operation on each and every row. It will execute once per row. For each row, it will execute this command. So, row relation, it is, we can call it as a row relation, and it will provide the new relation that it will not disturb the existing relation. Please remember that it will not disturb the existing relation. It will convert the given data set into another state and create the new relation. It will not disturb the previous one. If you want, you can use the previous one again. Okay, so that is the for each relation. How can we give that? For each relation, you have to provide the relation and generate the column or expressions you have to provide. Now let us see that here in the grunt shell dump A. Actually, here dump is a statement to display the content of the relation. Okay, as we have loaded the data set in the previous slide, so the data is like this: 1 comma Rama comma 5000 comma 1 and 1 comma 2 comma Krishna comma 6400 comma 3. Like this, this is the data set. Actually, whenever you give the dump, the that will execute the it will load. Actually, it will load the data into our program and it will display. Okay, and then B equal to, I'm creating another relation. Already we have the relation A, I'm creating the relation B. How we are creating is, for each A, generate ename comma $2 star 2. What is this ename? Ename is this one. Okay, and then $2 is $0, $1, $2, $3. So here 1, 2, 3, 4, this is the $0. Rama, Krishna, Kumar, all these are the $1. $2 is 5,000, 6,400 and all. So we are multiplying with 2, meaning that we are making it twice. Okay, and then as the salary, we are creating that as the salary. So we are creating that so that the result will be like this. We are just creating the new relation B with the e-name and the new salary. So that Rama and 10,000, Krishna 12,800. So like this. This is how we can create the relation by using the for each. And in the similar way, for each A, generate dot dot e name, meaning that before e name, all the columns will be included. And then e name dot dot means from the e name, all the remaining columns will be included. So like this, we can generate the new relations by using the for each. And next one is filter. I want to filter I want to filter some records. So how can we apply that? So filter relation by some expression. We can give some expression. Now you can see that filter A by salary greater than or equal to 7,000. So that is the condition they are giving. So which is having the salary greater than 7,000, all these will be filtered. So this is the filter command. Group by. The group by command, it will group the data set. It will group the relation by a particular column. Now you can see that C equal to group A by DID, department ID. So whenever you give this, the result will be department ID, department IDs. We have 4 department IDs. 1, 2, 3, 4. Department ID 1 comma, the related elements, all the related records are given as the list of tuples like this here. This is the first record, this is the second record of department number 1, this is the third record of department number 1. Department number 2, there are 3 records. Department number 3, there are these many records, and so on. So like this, number of records will be there. And for each, see, Now I want to get from this C, I want to generate group. Group means by default, the first column will be taken as the group. So group comma sum of, I want to get $1 dot salary. $1 dot salary means here in this relation, this is the 1, 2, 3, 4, this is the $0, and this entire line will be the $1. So $1 dot inside that salary. Salary is 5,500, 7,200, 5,000. All these will be sum up and then it will be given. So that the result will be department wise average salary will be given sum of salaries. Okay, and then order by. It is very simple as our SQL. So order by, it will sort the number of all the records based on the given column. So order by salary. Based on the salary, the records are arranged. Okay, and then join. You can join two relations by using the join. Okay, so here A equal to EMPJ1, B equal to DEPTJ1. So I just want to load them. I just want to, okay, so I just want to join them. CC equal to join A by DID, B by DID. There is a common element, common column is there. We are giving that join A by DID, B by DID. So if you see that we are getting that 6 comma Karthik comma 5500 comma 1 comma 1, these two are the department IDs and department name also given. Department name is available in the department table. Okay, so like this we can combine them, and in the similar way we can go for the left outer join and right outer join also you can perform. Okay, this is the join operation. So these are the various big commands available. So you can practice them. Thank you.